Do you own a diesel pickup? Filtration and air separation is far more important than you probably understand. Let's go through the basics of the injection, the pickup diesels that I can think of, and we'll kind of run through the basics of how they work so we can illustrate why air separation and fuel filtration is important. Starting with your IDIs, you got your 6.9 and your 7.3 in the Ford, you have like some Mitsubishi 6-cylinder in a Dodge who's only running 78, and then you have the 5.7, 6.2, and 6.5 in the Chevys, and then the plethora of other IDIs, but they all probably use a similar type injection pump. The ones off the top of my head are like the Stanadyne, the DB2. It's a rotary type injection pump, and it uses a slightly lower injection pressure than its direct injection diesel counterparts. So much so that I want to say the diesel, or the Stanadyne pop off on the injectors is somewhere around 2,000 psi, and I think it peaks somewhere shy of 8,000 psi, which is a lot if you think about it. But at the same time, once we get into other diesels, you're going to see that 8,000 psi isn't quite as bad, which actually brings us to why IDIs have to be IDI. That little bowl inside of the head that they use is actually because of that injection pressure being lower. That 8,000 doesn't completely atomize the fuel, so the burn needs a little bit more heat to happen. Or you can run like 20-to-1 compression, use that piston, and the air travel is going to go inside of that swirl, catch that fuel spray, atomize it more, start the burn. They also use a cam-driven fuel pump, and a lot of the Stanadyne pumps are actually deadheaded at the pump. There's no recirc, so you just have a cam bringing the fuel to the Stanadyne, injecting it. It's usually like a distributor type, so it runs like that, runs your fuel pressure up the line, reaches the pop-off PSI inside of the injector. That's what happens. And then you got the first direct injection diesel. That's the VE injected 12 valve. That actually uses a very similar style injection pump to the Stanadyne. It's still a rotary type with the lines that go to the pressure. The only difference here is that VE injection pump that you find inside of the 12 valve is capable of reaching 17,000 PSI. That is double, almost double, no, over double what a Stanadyne pump in the IDIs is reaching. So with that, we're going to see a more efficient burn, a better burn, but the VE pump also uses a cam-driven lift pump to supply the fuel, the low pressure fuel, to that injection pump. So you're talking lower PSI. The cam is going to be dependent on the engine, and then I believe it's also deadheaded at the injection pump, which brings us to the P7100, also found later in the 12 valves. That's a cam-driven, almost like a little engine. It's got 6 lines that come off the top of that, and it does the same thing. The only difference here, you can have a lot more volume of fuel, and the injection PSI is capable of reaching 19,000, so it'll bump up even from the VE pump. It still uses a cam style, a mechanical injection pump. This plunger goes back and forth. That's what sucks the fuel from your tank, supplies the low pressure fuel supply to your injection pump. Then we got the VP44 Cummins. Now this is actually very similar to the VE pump. The VP pump is just actually an electronic version almost. It's the first Cummins to use an electric fuel pump to supply the fuel to said pump, but in this case, not only is it supplying the fuel, it actually relies on that return, the recirculation of the fuel through that injection pump to cool this green circuit board right here. This is actually one of the commons on a VP injection pump. This circuit board gets overheated from fuel, and your stock lift pump will actually get tired, supply enough fuel to keep the injection pump running and keep the engine running, but it's not enough to recirc the fuel back. So now you're getting a lot more heat built up on an already failure-prone pump. This heat is going to melt the solder inside of this little green chip, whatever this was called. It's going to melt the solder in here, disconnect some electrical pumps, and then you could be left with a crank no start. It is worth noting that the VP pump also receives an injection PSI bump from that of the P7100. It is capable of reaching injection pressures of 19,500 PSI. That brings us to the most unique sort of fuel injection, in my opinion, that we find in the diesels, and that's the HUE injection system found on both the 7.3 Power Stroke and the 6-liter Power Stroke. Let's talk about the 7.3-liter Power Stroke injection system first. These HUE injectors use oil from the HPOP, supplied in oil rails, that creates the high pressure system, the hydraulics that actually go inside of this style injector, pushes a plunger down, that fuel enters at a low PSI, goes inside of this same injector. The oil piston pushes the fuel down, pressurizes the fuel, goes out the tip, and that system actually is capable of pressurizing that little fuel inside of the injector to 21,000 psi. So you can see how we're starting to snowball into some high pressures and some tighter tolerances. The 6-liter uses the same style system with some upgrades, some more voltage, and it's capable of reaching 30,000 psi inside of that injector nozzle. The 7.3 uses a lift pump found in the Valley, which is another mechanical style lift pump, and it deadheads the fuel to the low pressure supply of those Huey injectors. The 6-liter uses a pump found on the frame rail that has a recirc built into it, so it's actually supplying fuel, recirculating it back to the tank. Now we have our CP3 injected diesels. Now this includes your LB7s, your LLYs, your LBZs, your LMM, your 5.9 common rails, the early 6.7 common rails, a short stint where it was CP4, and then back to your 6.7 common rails. Even though there's a recall, CP3s were used a lot. Now here, the Duramax really exposed some weaknesses. Well, the CP3 is a more capable pump than was found in the LML, but that CP3 actually is used to draw the fuel from the fuel tank to the injection pump, so it has no low pressure fuel supply. It creates its own supply, and then it circulates, and it's a common rail system, so you have your fuel rails, your injectors to sit off of there, and they're actually electronically actuated, so there's PSI constantly in the rails, and then that injector just opens and closes, lets the fuel out, yada yada. The Cummins uses a tank style lift pump to supply the fuel to the CP3, and it's also on a recirc. I think all common rails have to use a recirc system. You can't just deadhead the fuel there, because then you'd have the back of the rails receiving less fuel than the front of the rails, and they're all recirced. Which brings us to the 6.4. The 6.4 is the most unique common rail. It's a K16 style injection pump, which actually has a lower injection PSI than that of the CP3. It only clocks in at 25,000 PSI. Now this one also uses a similar low pressure fuel pump like the 6-liter. It supplies the fuel to the K16 and then it recircs back to the tank. The only difference between like a K16 style and a CP3 style is that the K16 or a 6.4 uses piezo injectors, where the CP3 common rails all use solenoid type injectors. Which brings us to the injection pump that is the most famous for being a pile of crap. The CP4 uses in your LML Duramaxes, that short stint of Cummins right around that 2020 COVID area, and then your 6.7 Power Stroke from its inception to now. Now the 6.7 Power Stroke has seen, the original one is the same CP4 that was found in the LMLs, but then your later one is actually 10% above the LMLs, and they got an extra coating. I think it's DLC, similar to what the 6.0 injector coating was around 05 or 04, but then and then I think in 2020, that same CP4 got pin lifter buckets from the factory, so they do try to fix it. But here, the LML, this is where LML or Duramax really learned the hard way that a lift pump is kind of a necessity when it comes to diesels. You ask that CP4 that's already failure prone to run the possibility of working in a vacuum, you're gonna spin that lifter, or spin the bucket, land the lifter on the cam where it's no longer able to circulate like it's supposed to, grind it, get a bunch of glitter, failure, expensive failure. 6.7 does use a lift pump, but it's still a CP4. You're still dealing with tight tolerances, and then that CP4 is capable of making fuel rail pressures of up to 39,000 PSI. Which brings us to our last style injection pump that's found on these diesels. It's exclusive to the L5P, and that's an HP4, which is Denso's similar version to the CP4, but it is different. And for some reason, the LML and the 6.7 have to use piezo injectors, but the HP4 is able to utilize a very sophisticated solenoid type injector, and it's still really close to a piezo. That's piezos in the new Power Strokes are capable of 8 events per cycle, and the solenoids in the L5P are capable of 7. That is minuscule, and you're never going to notice that difference. And the HP4 does use a lift pump from the factory to supply the fuel to that injection, which brings us full circle back to the point of the video. Lift pumps, air separators. Why are they important? Why is diesel filtration important? Why is air separation important? Well, first, the filtration seems kind of like a no-brainer here, right? You want to get all the contaminants out of your diesel. You want to use the most microns that you can to filter out any contaminants, because when you start dealing with rail pressures up to like 20,000, 30,000, damn near 40,000 PSI, that is incredible, and that is a lot of pressure being built by these very, very fine tolerance components. You take something that has such a fine tolerance and you add something not so fine to it, you're gonna wear it out, and then you're looking at an expensive repair cost. But when it comes to lift pumps, like this Fast that I run on my 6.4, the real thing that I am most adamant about is the air separation. Air separation on diesel engines is extremely important. So if you look at the stages of matter, we know solids don't compress. Liquids have a very minuscule compression, but gases can compress a lot in like a short amount of time. So air separation, if you get the air out of your diesel, you're going to want to eliminate the chance of two-phase flow entering your injection pump, right? Injection pump, your injectors, anything that's pressurizing the fuel, if you have air bubbles entrapped into that fuel, when it goes to compress it to those crazy PSIs, you will see that PSI, but as it compresses it, now we're compressing the fuel, but if you have the air pockets in there, now that's taking the brunt of the compression. You're not actually compressing the fuel, you're compressing those air pockets, and as a little bit of pressure is released, the air pocket's gonna wanna expand, and you're going to drop the PSI that you see in that compressed area a lot faster. And that could lead to, if you don't have a failure, you can just see dropped rail pressure, you're gonna see harder starting pickups, you're gonna see less power, more smoke. You're not getting the fuel atomized if you don't see the injection pressure. So it's often overlooked, but air separation is crazy important. Just if you can get a single phase of diesel flow in any injection line, whether it's all the way to your 8,000 pounds you see in an IDI diesel up to the 39,000 PSI that you're seeing in a CP4, if you take the air out of that, you're gonna get a better atomization, a better burn, a more efficient burn, you're gonna lose less fuel for the same power, you're gonna have a cleaner engine that meets emissions easier. So in short, a lift pump, an air separation, whatever you use, absolutely beneficial to any style of diesel engine.